Searching far and wide. 7.6, the natural logarithm. LN is how it's abbreviated. All right, let's see. The natural log and Euler's number. The natural log is the inverse for Euler's number. So if you remember Euler's number that was on your calculator, and that it also has an inverse. Basically, what cancels Euler's number is the natural log, ln. So whenever you see these guys together, ln of e, they cancel each other out. And then when you see e raised to the ln power, they also cancel each other out. Okay, they're inverses of each other. All right. The natural log shares the same properties as the regular logarithms. So if I asked you to combine these two as one natural log, you would do the same thing as if it were a regular log problem. First, you would take the 2 that's in the front, bring it up here as an exponent, just like that, which we know 4 squared is 16. And then to combine them with the minus sign in between, we would divide. And that's how you get natural log of 2. All right? So the natural log has the same properties as regular log. All right, let's look at some special properties. Now, a couple weeks back, I showed you this property already when you had base 7 log of base 7. Whenever the bases match up, they cancel out, and we have just 5. Now let's do some of those properties with the natural log and Euler's number. Whenever you see, remember I told you in the first slide, e raised to the ln, they cancel each other out. And you're left with an 8. This one is just a little bit tricky because there's a 2 right here. Remember, you bring the 2 to the exponent, so it looks like that. And then you have, again, e ln, e raised to the ln power. They cancel each other out, and you have 7 squared, which is just 49. Here we have ln e. There it is, again, inverses of each other. They cancel out, and you have 13. And then this one, here we have ln of e again, which they cancel out. But before we do anything, let's go ahead and bring it either way. You can bring the 5 to the front or the 4 to the top. I brought it to the front. The ln e cancels each other out, and we're just left with 20. Either way. On your calculator, go ahead and see ln1. What does ln1 do? ln1 is just 0, and then ln of 0 does not exist. All right, moving on. All right, let's solve some equations with the natural log in it. Here we have ln of x plus 2 equals ln of 9. Just like regular log, if there's 1 on one side and 1 on the other side, they just cancel out. And you're left with a pretty simple equation, x equals 7. This one, there's 1 on each side. Before you cancel out though, let's go ahead and move this 5 up here to get that. Obviously we know 2 to the 5th power is 32. Now we can just go ahead and cancel the natural logs on both sides, and we're left with a very simple x minus 4 equals 32. Add 4 to both sides, and the answer is x equals 36. Let's do one more. This one's a little bit tricky just because there's so many natural logs in the problem, but we know that we can combine the natural logs just like we combined regular logs. So this one, the two natural logs are separated by a minus sign, so remember, to combine them, it turns into a division problem. Okay, and now there's just one natural log on each side. Cancel them out, and we're left with an easy equation. Let's get rid of this denominator by multiplying it to the other side. Distributive property, and then use basic math to get x equals 6. Okay? All right, let's do some tricky natural log equations. ln of x is equal to 3. That looks simple because it's a very short equation, but if you notice, there is no natural log on the right-hand side, so there's nothing to cancel out. So how do we get rid of that natural log? How do we get rid of a natural log when there's not one on the other side? Remember, natural log has an inverse, and the inverse is Euler's number, e. All right, so what we do is we put e as the base and then raise the problem up as an exponent. And if we do that to both sides, then for algebra, that's okay. As long as we do the same thing to both sides, our equation stays the same. So we're going to raise both sides to an exponent and put e as the base. And the reason why we do that is, notice this will cancel out. And you're going to be left with just x equals e to the third power. Now, how do we do e to the third power? Let's pull out your calculator. All right, so if you have a TI-84, there should be an e right there. There's another e actually that's right over here. I know it's kind of hard to tell. But if you have your calculator in front of your face, you can see it. I have my calculator right here, so I can see where the Euler's number is. So you can use either one of those options to put e raised to the third power, and it should give you approximately 20.0855. All right, let's try another one. A natural log of x minus 1 is equal to 15. Notice on the right hand side there is no ln, so you can't cancel it out. So the way you would do it is you put e on both sides and raise the whole problem up. This will cancel each other out. And you have x minus 1 is equal to, I punched in e to the 15th in my calculator to get that huge number. Add 1 to both sides, and there's my final answer. One more of these natural log problems. Let's start off with this 2 right here. You can either divide the 2 to the other side, or you can bring the 2 as an exponent. Your choice. You will get the same answer both ways. I decided to bring it up in the exponent just for fun. Raise it to the e. These guys will go away. You have 36x squared is equal to that huge number when I punched e to the 14th into the calculator. Divide both sides by 36 to get that, and then square root both sides. And remember, whenever you square root both sides, you have two answers, a plus or a minus. But it turns out that if you check your answers, if you plug the positive part into the answer, it will work. But if you plug the negative answer back into the problem, it won't work. So we're only going to use the positive answer. All right, our last slide of the day, solving equations with e in them. All right, as you can see, there's our e problem. How do we get rid of that e? You ln both sides because e's inverse is ln, natural log. All right, again, if you do something to one side, you have to do it to the other. Notice we didn't raise it to the exponent. We just put an ln in front of both of them because this, we know, will cancel out. And we're left with a 3x equals ln of 15. All right, let's show you where ln of 15 is on your calculator. All right, natural log actually has its own button. It's this whole button right here. So if you put ln of 15, your calculator will give you the answer. For those of you guys who are using Desmos, Desmos also has the ln button. This is the Desmos website. You have to go to the very bottom of your screen where it has a keyboard right here. If you click on the keyboard, the whole keyboard calculator pops up. You would go to the functions button, and then when you open functions, you have to go to miscellaneous. All right, so you have to do all those steps just to get to the ln. The ln's right here. And then in case you're wondering, I think the log is also here. If you've been doing logs on your regular calculator, you can also do log in Desmos. All right, so punch ln of 15 into your calculator, and you should get 2.7081. Divide both sides by 3, and there's our answer. Let's do one last example for the day. All right, there it is, an E equation. Let's go ahead and get rid of that 12 first. Bring the 12 to the other side, subtracting it to the 18. And then to get rid of the E, we're going to ln both sides. Notice the ln and the E will cancel out. You have negative x is equal to 1.7918. And then to get rid of the negative, bring it over to the other side, and there's your answer. All right, go ahead, try the homework, see how you guys do.